we are given 2 sine x plus square root of 3 equals 0. We need to find the solution of this trig equation in the interval 0 to 2 pi in first part, and the second part then we say find all the solutions of this in the form where x equals a plus b k pi. Then we'll see what is a, what is b, and how many results we can determine. So first of all, try to solve this equation in terms of sine x. So we will get the following. So we get 2 sine x equals negative square root of 3 by subtracting square root of 3 both sides, and then divide both sides by 2. So when I have sine x equals negative square root of 3 over 2, I just want to see where radical 3 over 2 we have for sine x as a reference angle. So we know it is pi by 3. And since sine x is negative, that must be in quadrant 3 and in quadrant 4. So what is this in quadrant 3? So x will be that one, which is pi plus pi over 3. When you simplify, this is 4 pi over 3. So this is one angle. Another one, I can say from here to here, which is 2 pi minus pi over 3. If you simplify, you get 5 pi over 3. So we got this format. So for this part, our solution now we can say x equals x equals 4 pi over 3 and 5 pi over 3. So we are done for the first part. Now for the second part, we'll be using those angles. Now see that this 4 pi over 3 always will be coming with 2 pi if I just add. So then I just say that for all solutions, my x will be 2 pi, you can say k times k is an integer. So if you multiply by 1, it goes 1 rotation. If you multiply by 2, 2 rotations, and so on. So we say 2k pi 4 pi over 3. Another one I can say 2 pi k or 2k pi plus 5 pi over 3. Now if you compare these results with this format in here, then you can see A is a free one. So you can say A equals 4 pi by 3. Also you can say 5 pi by 3. And then your B will be, just compare. We say here bk pi. So you have 2k pi. So then B must be 2. So sometimes in questions we say if you have more than one solutions, write x equals a plus bk pi or c plus dk pi. Then we may ask to find what is a, what is b, what is c, what is d. I'm taking another example where we need to find all the solutions of cosine x times 2 sine x plus 1 equals 0 in the interval 0 to 2 pi. And then the second part we are saying find all solutions. Means many times you can have with the rotations, and then your solution should be written as x equals a plus k pi, or x equals b plus 2k pi, or x equals c plus 2k pi, where a is between 0 to pi and bc has this relation between 0 and 2 pi. So to solve this problem, first we take the equation and solve for sine x and cosine x using zero properties, because this is already in factor form. So we can say cosine x is 0. So if my cosine x is 0, then x must be pi over 2 or 3 pi over 2. We know this already, because you can see cosine is 0 here and here. This is pi by 2 and this is 3 pi by 2. So when I'm looking for solution in these, then I say x equals pi by 2 and x equals 3 pi by 2. The other part, I have 2 sine x plus 1 equals 0. If I solve for sine x, I'll get this is negative half. So if we look at the reference angle for 1/2, so we know that sine has 1/2 when the angle is pi over 6 or 30 degree. So then with this reference angle, we can take the value of sine x equals -½ will go here in the third quadrant or in the fourth quadrant. So in the third quadrant, my x value will be now pi plus pi over 6. And here, with this whole rotation on these, will be 2 pi minus pi over 6, which is 11 pi over 6. So then I'm getting x equals either 7 pi over 6, which is coming from here, and the other one is 11 pi over 6. So we got our solution for the function here in 0 to 2 pi. Now we'll be going to the second one. So the second one, we need to find the general solution. We may write our solution as x equals a plus k pi, or x equals b plus 2k pi, or x equals c plus 2k pi. We'll see why we are giving you all these options. So first look at here. When we are looking for our cosine x solutions, we get pi by 2 and 3 pi by 2 in this interval. Now when I make a general solution, I can just see that if I add pi with this, I will come here. If I add another pi, I will go there. So in this format, I can use only this angle. So in that case, I can say my general solution for second part, x will be pi over 2 plus k pi. I don't have to take 3 pi over 2, because when my k is 1, it automatically goes in 3 pi by 2. So this is the solution for this part written in this form. Then you can say your a is pi over 2. Now for the second part, for this portion that we got sine x is -½ and these are our solutions in this interval. Now when I'm writing as a general solution, you can easily understand that I need to come back this one every time with one complete rotation. So that means if I just add here 2 pi every time, like either 2 pi or 4 pi or 6 pi or 8 pi like that, always I'll be here. Same on this. So that's why we are adding 2k pi. So then you have x equals, for this angle will be 7 pi over 6 plus 2k pi. Then if you compare with the first one, your b will be 7 pi over 6. When I'm taking this angle, I can again write my solution as, and then I can compare for that one, and I say my c will be 11 pi over 6, and I'm completely done.